Hello everyone, my name is Lauri Karanko and I will be presenting today about the potential use of knowledge bases to boost the efficiency of the natural language processing technique sentiment analysis. And as the topic of this presentation is sentiment analysis and knowledge bases, we'll have a short look into what these terms actually mean and encompass. To start with, sentiment analysis distilled to its most basic explanation is a method to learn whether some data is negative, positive or neutral on some opinion. So what does this mean? Humans can and often will express their opinions through language. So this tool called sentiment analysis exists to allow us to mine these opinions from textual data by scoring the contents of the data on this negative-positive axis. Also, the term sentiment analysis is interchangeable with opinion mining. So both words mean the exact same thing, just so you know if I end up using either during this presentation. Sentiment analysis can be used for several purposes, but mainly it boils down to the following. Sorting large-scale data. For example, often there's more people requesting for customer support than those providing it. Sentiment analysis can sort and match the issues of those customers to most likely solutions or support staff, relieving staff from manually sorting these requests. Sentiment analysis can also identify trends or important events in the data in real time. As another example, before another human has even had time to read a new tweet, a system using sentiment analysis could have already determined whether the tweeter was expressing their rage or contentedness towards that new appliance or politician's stance. Fast identification leads to fast responses. With how differently people can interpret the sentiments of their peers online, or the sentiment of some piece of text, it's also no wonder that these evaluations by people will not always agree with each other. People can also change how they view a subject depending on their mood. A system utilizing sentiment analysis will be more consistent when it comes to evaluating these sentiments of some data, garnering results that might be better compared with each other by removing human subjectivity from the equation. In addition to the techniques used for sentiment analysis, the precision and accuracy of sentiment analysis is dependent on the sentiment lexicons used. A lexicon is a vocabulary of words and phrases, while an opinion or sentiment lexicon is a collection of opinion words associated with some sentiment. Hence, one could search through a generic sentiment lexicon for the adjective blood-curdling and most likely find that the term is associated with a negative sentiment, while the phrase sparks joy could be expected to have a positive sentiment attached to it. Of course, sentiment lexicons and lexicons in general are built for a specific domain or area of research, causing terms to have differing sentiments in different domains. A sentiment lexicon built to analyze horror film reviews could rate the polarity of the previously mentioned term blood-curdling positively. Thus, a general sentiment lexicon for opinion mining contains a list of words, terms or phrases, and whether the terms is related to a bad, neutral or good sentiment. Therefore, when this lexicon is used to analyze a body of text with a sentiment analysis technique, the technique can then refer to the lexicon to gauge the sentiment behind the word or term. This sentiment is often referred to as the polarity or sentiment orientation of the term. Now, after this foray into what lexicons are, I will reveal that not all types of sentiment analysis even utilize sentiment lexicons. Sentiment analysis is typically divided into three different categories depending on the technique used, which are knowledge-based techniques, statistical methods, and hybrid methods. Statistical methods for sentiment analysis contain the subset of methods that rely on machine learning, which can skip the requirements for having a semantic lexicon, which is either generated manually or with text mining techniques. Using machine learning classification methods, there is no need for pre-annotated dictionaries of sentiments to terms. This is due to the more commonly used supervised machine learning classifiers training on features extracted from the corpus. These classifiers rely normally on naive Bayes and maximum entropy for their classification. Knowledge-based techniques, on the other hand, require some prior pre-annotated dictionaries of sentiments to terms, such as sentiment lexicons, to predict the polarity of the text or material under examination. Next, we will have a short intro into knowledge bases, one of the namesakes of the topic of this presentation. So, what are knowledge bases anyway? Knowledge bases, which in this setting are similar to knowledge graphs, could be thought to be the next evolutionary step from simple lexicons. A knowledge base contains terms and words, but links these terms to other words in a graph while also describing the relation of the linked terms. So how are these knowledge graphs related to sentiment analysis? Well, it happens that for knowledge-based sentiment analysis, a knowledge graph can be combined with a sentiment lexicon, thus creating a repository of sentiment information called a sentiment network. Now, when evaluating the polarity of a term, we can also evaluate related terms in this network to achieve a nuanced look at the possible sentiment for that term within its context. So now, when evaluating an entity in a sentiment network for books or films, such as the term Jurassic Park, we can simultaneously check polarities for actors and actresses related to the film or other themes revolving around this classic. Let's have a look at ConceptNet. It's a semantic network or knowledge graph which is hosted online. Let's search elephant, for example. And we can see all the related terms that come with elephant. There's a lot of different things. Locations an elephant might be, features that an elephant might have, and different languages or words for elephant. Let's have a look at, for example, pineapple. Here we can see also different words for a pineapple, but something to note is a pineapple is not a citrus fruit. So with these automatically generated knowledge graphs, there can sometimes be mistakes as well. So here is the research question for this topic. When is sentiment analysis improved by knowledge bases? Or are there situations where knowledge bases are required for sentiment analysis? So what we know is sentiment analysis typically relies on word lexicons, and a knowledge base is bigger in scope and shows the relationships of words and terms to each other. Unfortunately, there hasn't been a lot of recent research into combining knowledge base and sentiment analysis, but that's why we're delving into what contemporary sources can tell us. So could better opinion mining accuracy and prediction be achieved? And when to use these knowledge bases if so? So why knowledge bases are powerful and useful for sentiment analysis? Some terms in semantic lexicons will just be ambiguous in nature, as the polarity experiences swings to both positive and negative in text corpuses. In these situations, it's possible to enrich the amount of information available to us by attempting to guess the context of the word using knowledge graphs. When multiple related words or terms are examined simultaneously, it is possible to remove some of the ambiguity that a word might mean something else in a situation, allowing more accurate polarity values to be assigned to the text. Word closeness to other words in the text can be evaluated when employing a knowledge graph by viewing whether words have relations to each other within a certain number of steps in the graph. With word closeness being confirmed, it is possible to ignore other interpretations of the word that can have differing semantic polarity. Even words that are lacking from a sentiment lexicon, such as SentiCnet, can be given sentiment polarity values by evaluating the polarities of words close to the term in another knowledge graph. By removing ambiguity, we have now generated a domain-specific semantic lexicon, which will be more performant for that specific task it was made for. In this image, we can see how the relations in a knowledge base describe the relationship between the entities or terms in now domain-specific knowledge base. In this small knowledge base for the film The Addiction, existing sentiment data is enriched by sentiment features selected from the movie review. This is the result of the hybrid technique, where the machine learning was used to first find features, and these were joined to a knowledge base that already contained sentiment data for the concepts for The Addiction, 1995, Katie Viorant, and Performance. This new knowledge base is able to answer more specific questions about the movie. From another article, here's more on enriching a lexicon instead of a full sentiment network. This example uses the ConceptNet knowledge base, which we just previously had a look at, to search for the term approach, then examining the graph of terms and concepts that are related to the term on the left. These candidate concepts for the word are then searched again with ConceptNet, and their most relevant relations are then returned. They can be seen here on the right then. This approach, on the other hand, doesn't rely on machine learning or statistical methods, so enriching a lexicon in this manner is purely a knowledge-based technique. So, as we have learned, hybrid techniques combine machine learning and knowledge bases, which is what we want to familiarize ourselves with to better answer our research question. Next, we will have a look at a complete hybrid solution to a sentiment analysis problem, which includes several phases that depend on techniques from both disciplines. So, here is a hybrid sentiment analysis workflow aimed to numerically classify movie reviews from an article by Al-Farajani et al. This was the most impressive hybrid solution for sentiment analysis I was able to find. We can see that the content of the review at the top is sent both to be processed with natural language processing methods, while also being used to populate a knowledge base. A list of sentiments is extracted and matched with features that have been chosen as important from the knowledge base, which then are associated with sentiments from the review. Initially, on the right, a domain-specific movie knowledge base is created or used around the concept of movies, actors, scripts, performances and such, with their relations. These form the ground facts for a knowledge base, and this data is supported by gathering specific movie-related facts from open-source movie databases, like data on specific actors and actresses for the movies for which reviews will be analyzed. The aim is to generate a knowledge base with semantically structured, accurate data on aspects of each movie, which will then be used for the domain feature extraction task. On the NLP side, natural language processing is used to process reviews into their basic grammatical structures to enhance domain feature extraction. Finally, we are now matching terms from the grammatically deconstructed review with entities in the knowledge base, leveraging the ability to match with synonyms or related terms. Review terms such as actors and other ground facts match with their counterparts in the knowledge base. Even pronouns like he, she, it, or first names and such are mapped to people and entities in the knowledge base that were mentioned in the review, so as not to generate extra entities. On the very left, you can see that a previously prepared list of sentiment terms, which scores words such as great, bad, interesting is used. This list is then pared down to the only to the relevant words in the reviews. After all this work, we finally begin work on the classification. Patterns in the grammatically deconstructed review text, which contain both domain features and sentiment data, are retained as feature-sentiment pairs as long as these are subjective opinion statements. The subjectivity of a statement is revealed by the deconstructed review grammar. Now, domain feature polarity is determined by scoring the individual domain feature pairs and then aggregating the results for each opinion phrase, resulting in scores, or in other words, polarity values for each term. These terms with scores are then used to enrich the knowledge base by attaching sentiments and opinion polarity values to the correct knowledge base entity, such as an actor, scene, or genre mentioned in the review. So, from our improved knowledge base, which is now a semantic sentiment network, a semantic feature matrix is generated, as this format is necessary for machine learning classification algorithms to process the data. In this model, an additional vector space model is created from the original review data to save the frequency of all the features appearing in the reviews. Features that have similar polarity values for their domain features can have their columns combined to create a less sparse matrix for the machine learning algorithm to handle, leading to a better training phase for the ML phase. And both semantic and statistical feature matrices are then concatenated, normalized, and passed to review classification machine learning algorithm, which in this paper's case was a support vector machine. But it could be actually almost any classification algorithm that accepts matrices. Here's another look at what the knowledge base or domain concept map for the movie opinion review could resemble in its structure. Note that the IDs of individual reviewers can be saved into the knowledge base as relations to their opinions or reviews, possibly allowing reviewer-specific sentiment analysis as well. Next, we will look at some of the results from some of our articles that employed knowledge bases for classification and enrichment with and without machine learning. So, is it worth using knowledge bases? Here, Al-Farajani et al. Showed that their results when it came to classifying IMDb movie reviews were improved when using their hybrid method, which we just looked into now. As we can see, there is roughly a 2% improvement when using the statistical semantic dataset compared to solely the statistical data. And the statistical semantic dataset is the enriched knowledge base data. Weichel-Brown et al. From the Seed article showed that using the knowledge base method to generate more context terms aided in the disambiguation of sentiment terms considered ambiguous in the Amazon reviews and IMDb reviews corpuses. On the left, we can see how a single ambiguous term like development had context terms collected for it from the Amazon reviews. Then these context terms were given a polarity. The semantic networks, ConceptNet and WordNet, were then examined for related terms that matched with the polarity. In the ConceptNet and WordNet brackets, we can see that the phrases and words that the Weichel-Brown teams conceptualized as system thought to relate to the term and their context terms. On the right, the authors showed the amount of the new terms they were able to generate that had a sentiment or polarity attached to them, making it easier to determine whether terms such as development correlated with a negative or positive review by allowing the authors to look and use these new terms from these semantic networks. These results or new terms could then be used in any lexicon or knowledge-based classification system, ideally increasing their accuracy and precision. These, on the other hand, are the results from an article from Dawe et al., who classified social media data, for which the knowledge base was generated automatically using a commercial software called LIWCA 2015. It would seem that the machine learning-based approach almost loses out to the combined approach, but in this case, with only 425 comments to analyze, the machine learning-based approach becomes weaker due to having less data from which to extract features. Still, the machine learning-based approach beats the hybrid and lexicon-based approach here in the negative sentiment classification task, so hybrid methods can't be said to be an absolute improvement. So, what can we conclude from these results? Combining lexicon-based and machine learning approaches can yield improved results in some situations, and this is especially true when there is a lot of data points to look. But the machine learning methods, they were often seen to outperform statistical lexicon-based approaches, except when the length of the data examined got shorter, causing the precision and accuracy of knowledge-based methods to overtake that of machine learning methods. One area of interest where this occurs is tweets, with their 140 character limit per message. So knowledge-based methods were able to outperform machine learning-based methods in these cases. The integration of the semantic knowledge base and machine learning methods has emerged as an effective approach for improving the process of opinion mining at domain feature levels, but in particular for enhancing the opinion classification task. But nowadays there's less use for solely knowledge-based approaches, and it'll be interesting to see the application of knowledge-based methods with larger datasets. So using deep learning techniques instead of conventional machine learning techniques, which is something that hasn't really been done yet. Now, let's examine some of the issues with using knowledge bases for sentiment analysis. Creating a semantic sentiment knowledge base that contains enough domain-specific relations can be quite time-consuming. Automatic data mining systems can generate knowledge bases, but as we saw with the Pineapple ConceptNet example, this can lead to having faulty relations. The best knowledge-based graphs are vetted by real humans. Hybrid methods are also far harder to set up compared to just statistical and knowledge-based methods when it comes to sentiment analysis, as there has been far less research on the topic. Here is also some further reading on the use of knowledge bases and sentiment analysis in the real world currently. Unfortunately, it is hard to find information on the sentiment analysis systems currently in use by large corporations, which could in theory also be leveraging hybrid methods for sentiment analysis. It would seem that with services like Kraken, they offer most of the components to set up sentiment analysis with knowledge bases as a platform as a service model, Some companies, such as the aptly named Semantic Web, also offer services to build systems that operate using knowledge bases and graphs. As it is, hopefully, in the future there will be more adopters and transparency on how knowledge bases might be used for sentiment analysis outside of academia. Thank you very much. This concludes the presentation. I hope this makes you appreciate what knowledge bases and graphs could be used for in your future endeavors, whether your efforts lie within the field of machine learning or something else where knowledge bases could find a foothold.